Okay, welcome back. What I want to look at today is Sitting Gill's certificate in electrotechnical technology. Now, this is where you are training to be an electrician, okay? Nothing less. Now, remember, being an electrician and once you're qualified, open many doors. Excuse me. You can end up working in maintenance, power transmission, main overhead lines, so forth. Your field of work is diverse. There's no limit to your ability to what you can achieve once you're qualified. Okay. Now here, application of health and safety and electrical principles, outcome 3. Okay, describe the basic principle of operation of electrical machines and alternating current theory. Okay. And here are your expected outcomes. Sorry, let me just go back. I went through that a little bit too fast. Understand how an AC machine works. Okay. Make sure we get this into full view. Okay. Now this motor and the DC generator works in the same way. The commutator either smooths out the generated EMF or chops it up to create a change in magnetic field in the armature. The constant magnetic field created by the field winding interacts with the change in magnetic field in the armature, causing the motor to rotate. And this is what we're reading here, okay? Sorry a second. Okay, that's better. So, okay, one second, give me a second now. Sorry about that. I've had turned off everything earlier. So, okay, let's hope that's a bit better now. Okay. Okay. Now, three-phase induction motor. The generator consists of 3 separate electrical windings, coils. These are placed 120 degrees apart. When the rotor turns within a magnetic field, these windings produce an induced EMF. These windings produce a 3-phase supply as the induced EMF in each winding is always rising or falling at different points in the AC cycle. Brown phase, black phase, grey phase, and again commencing brown phase, black phase, grey phase, and so on and so on and so on. Okay? Okay. The squirrel cage induction motor. There are 2 general types of 3-phase motors, wound loop motors and squirrel cage. Here is the outlet, design or idea as to your squirrel cage motor. Squirrel cage rotor, okay, located here, showing the ends of the rotor bars. Okay, that's your stator around here. Okay, shaft, cooling fins. Okay, that's your terminal box where your 3-phase system will be brought in to connect to the motor. And here is purely a cutaway view of rotor. Okay, let's see if we can bring that into play for you as well. Okay. Just want to make sure that you can see everything on here. I probably could have made the letter sizes a bit larger, but I'm hoping that they will be quite readable. Okay. Screw cage induction motor. Now, a three-phase motor operates as with any other electrical machine by the interaction between two magnetic fields, but it is just a little more complicated. The supply is connected to the stator of the motor. The stator is the electrical windings around the outside non-moving part of the motor. They are fixed and don't move. The supply is connected by either star or delta, and that is your style of connection. Okay. When the supply is turned on, a three-phase supply is connected across the three sets of windings. Because of the rise and fall of the magnetic field at three different times, it produces a rotating magnetic field. Okay, and that's your three-phase cycle. And here we're just showing you what that looks like in the diagram here. Okay. Okay. I hope that will give you a good picture of that. Let's pull back a bit. Okay. Sorry about that. Now, synchronous speed. When the magnetic field rises and falls at the same frequency as the supply, we call this synchronous speed. Now, the rotor of this type of machine contains thick bars of aluminium, shorted at the end by aluminium rings. The rotor also has a laminated steel core which concentrates the magnetic field. Okay, and I'm just giving you a view of that there. We'll go down, make sure we can get that in the view. Okay, now this is what it looks like here. Okay, so sorry about that. Just let's get this into full view. Okay, bearings. Okay, your shaft edge here. Okay, and it's just showing you that how that is connected up to be driven. Cross-sectional area view of a lamination not to scale. Okay, holes cut out of laminations to help reduce weight. Okay. Cross-sectional view of a rotor bar not to scale. Okay, and here all it's doing here is showing you your lamination pieces in respect of the motor. Okay, that's your locking key. Is to make sure that the motor stays in one position and rotates only in that position. Shorting rings, okay, at each end here. Okay, that's your rotor bar, which is here. This is what this is here. This here will be your shorting rings here. Okay, same thing here as well. That's here. Okay, these bearings here. Let me just go down a little bit to show you. These bearings here tend to wear after a period of time, so they need to be well lubricated to make sure to minimize wear. If they begin to wear, this here begins to move within the stator and will cause damage. Okay, Okay. We will assume that the direction of the rotating magnetic field is to the right, and that the magnetic field is flowing from the stator to the rotor. And here we have our stator. That's our stator. And these are our coils in our stator. Okay. Here, stator conductors. Okay. Now here is our rotor. And as previously shown, you can see that this indicates our rotor position here. Okay. Rotor bars. These are our little bars, each bar. Okay, support. That goes to make up the rotor. Now, direction of current flow through the conductor. Now here, let's look at the direction of current flow. You can see that here, the current flow is coming towards me because the arrowhead is coming towards me. Now, look back at the work you did for me previously on one or two slides in electrical principles, okay? In magnetism, especially, okay? So you can see that that's an arrowhead. Imagine that coming towards me. So you can see that your magnetic field is rotating anti-clockwise, okay? And your current flow is coming out towards you, okay? So it's coming towards you. Woof, okay? Current coming towards you. Right, okay? Sorry about that. Okay. Now, let me just move back. So we can get you in frame, okay? Now this will create an induced EMF in the conductor which produces a current flow to be flowing out of the page. As I said, it's flowing out of the page, coming towards you, okay? Sorry about that, that's another point there. Out of the page. Remember Fleming's right hand rule. Now again, remember the hand rule, Fleming's right hand rule. And also you also have a left hand rule. And you need to look at those up because they are already in the electrical principles format. Okay? We know the direction of the current in the conductor, and we can determine the direction of the magnetic field surrounding it. Okay. Now torque. As the rotating magnetic field passes each of the rotor bars, an EMF is created in each bar. This in turn creates an induced current. The rotor bars are shorted out at each end, which shorts out the induced current, creating a large magnetic field in the rotor. Okay, and here we are, still stator, the interaction of fields of stator. Okay, so it's just telling you now, as the rotor rotates, it have an impact on each of these coils in the stator. Okay, so magnetic fields, rotor, direction of induced current in the rotor bars, magnetic field set up by the induced current, direction of motion of the rotor. Okay, so here now, looking at this now, direction of the motion of the rotor. This is indicating that the motor would be rotating clockwise. Rotation of the magnetic field. Yes, that would be correct. The motor must rotate in the direction of the rotating magnetic field, so it's going to be driven in that position. Yes. Okay, again, do some research for yourselves. Make sure you understand the concepts in regards to the magnetic field setup in the stator and the rotor. The interaction of the two magnetic field causes the rotor to turn in the same direction as the rotating magnetic field. Okay, so as if the rotating magnetic field is rotating, it's going to be drive the motor in that direction. So that's what's happening here in this case. Okay. And this rotation here indicates that this will be going clockwise. Just making sure you can see everything and the direction as it goes and so forth. I want as much information as possible on this. Okay. Let's just make sure we can get that in. Okay. Okay, let's just get it up now. Make sure we can get you back up. Okay. Okay. Okay, I think that should do us. Okay, there. Right. Now again, remember, PowerPoint slides only give you a snapshot of what's happening. Okay, you need to do additional reading, okay, and so forth, and look at the specifications and regulations that relate to motors in regards to the IEE or IET regulations. Okay, wound rotor. Okay, wound rotor showing the conductors let into the slots. Okay. And here what we're saying here is that this rotor has a coil system in it. Okay, that's your stator, that's your wound rotor system here. Okay, diagram shows a three-phase wound rotor induction motor. A wound rotor motor is not as common as a squirrel cage motor, but it has the ability to control speed and the loading of the rotor. Okay. I'm just going, make sure we get this in full view. Okay. 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 Let's just put down a little bit. Okay. Okay, that will be us for the time being. I'm gonna have a look at this and see how it comes out, and I hope you found this useful. Okay. Have a good day. Bye bye for now. Thank you.